All right, so we are going to do some Pythagorean theorem. We have done this before. We did this in junior high. We did this in algebra. So this is a repeat still of Pythagorean's theorem, but we just got to make sure that we understand what it is we're doing. All right, so triangles can be classified by their sides using the coordinates of their vertices. So let me turn my pen on and change this to green. Vertices. Oh my, I don't know what my computer is doing. Let's try this again. There we go. Y'all, my iPad's tripping. Oh, vertices. There we go. All right. Calculate the length of each side by using each pair of coordinates. And to the distance formula. If Delta Math is requiring you to do the distance formula, they will give you that equation, so don't stress about needing to know that off the top of your head, okay? Main thing is we want to compare side lengths to determine if the triangle is acute, obtuse, or right. To find the perimeter of the triangle, we add up all three sides, and we can also classify a triangle by its sides. We talked about that. We talked about that and the perimeter thing in another unit. To test the longest side C to classify, we're going to use Pythagorean. If C squared is greater, it is obtuse. If it's equal, it is right. And if it's less than, it's acute. All right, let me change colors because I don't like that color. All right, let's look at page 2. So up at the top, we want to determine if the side lengths make acute, obtuse, or right. And I'm going to split screen this so that you can see this with Desmos. To make sure that you know how to put this in Desmos. All right, so in case you didn't remember, A is always going to be my shortest side. C is always going to be my longest side. So when I do this, I have A is equal to 8, B is equal to 15, C is equal to 20. Because then I have 8 squared plus 15 squared, and I don't know how that relates to 20 squared. So I'm in Desmos. I'm just going to put it all in at the same time. 8 squared plus 15 squared. Oops, that's a 1. 15 squared. Y'all, I'm just struggling. I'm ready to go home. 15 squared. So that's 289. 20 squared is 400. So 400 is greater, so I have an obtuse triangle. There we go. Same process. So A squared, A, B, C. So I have 15, 22, and 25. So I have 15 squared plus 22 squared. We don't know how that relates to 25 squared. So I have 15, I don't know why it's not wanting to do that. 15, there we go, squared plus 22 squared is going to be 709. 25 squared is going to be 625. Yep. So this is smaller, so this is acute. I have A, B, and C, 35 and 37. So I have 12 squared plus 35 squared, and I need to know how it relates to 37 squared. So I have 12 squared plus 35 squared. So I have 1369. And then I have 37 squared, and I have 1369 again. Those are equal, so this is a right triangle. All right, over here, what you're going to notice down below is I gave you cheats, right? So our formula is here, right? We know that. We know A and B are legs. We know C is the hypotenuse. We know all that. We've done all that. We've looked all that. In order to find things, if I'm looking for side C, so if I'm looking for my hypotenuse, this is what I'm plugging into Desmos all at the same time. If I'm looking at A or B, needing either of those, the only difference is C is going to be first, and I have to subtract the other, okay? So below that are the steps. Let's look at some examples over here on the next page. All right, this is going to be A. This is going to be B. This is going to be C. So I'm looking for C. So C, according to our little chart, was A squared plus B squared. A is going to be 8. B is going to be 6. And I'm going to put that entire thing in Desmos at once. So 8 squared plus 6 squared is going to be 10. Same process. This is going to be A, B, and C. So I'm looking for B rather. So B is going to be equal to C squared minus A squared. This is going to get a little messy, so just bear with me. So C is going to be 16 minus 12 squared. So over here, 16 squared minus 12 squared. Notice I get a decimal. If Delta Math says round to the nearest whatever, fantastic. Otherwise, what they're asking you for is simplest radical form. So we need to simplify our radical. So 16 squared gives me 256 minus 144. That's going to give me square root of 112. That is not simplest form, so what I need to do is simplify. Because it's an even number, I'm just going to divide by 2. So I have 112 divided by 2. That's going to be 56. 56 is not prime, and it's not a perfect square, so I'm going to simplify it again. Again, I'm just going to divide. So 56 divided by 2 gives me 28. That's an 8. My bad. And I guess I should mute that. Focus. Nope. Oh, what did I do? Y'all, hold on. Do not disturb. There we go. All right. This. And back over here. I got all sidetracked, wonky. Yeah, it was just bad, wasn't it, y'all? And I'm going to delete that. There we go. All right, back to this. And 2, and I'm bringing that 2 down. You cannot lose your 2's along the way. 28, I can divide again. So 28 divided by 2 is going to be 14 and 2, and I still have the other 2's. Dividing yet again because I have to get down to all prime numbers. So notice now I'm at all prime numbers. Anytime that we do this, groupings of 2, 1 comes out. Groupings of 2, 1 comes out. Whatever's left stays under my square root. So I have my square root. That 7 is going to go under that square root, right? 2 times 2 gives me 4, so B is going to be 4 square roots of 7. Now, another example, and I'm going to do this in red so that it shows up. Say, for example, you have, 27, square root of 27, right? My factors of that are 9 and 3. I said over here at this step, 56 was not a perfect square. Perfect squares meaning that when I take a number by itself and multiply, I get that number. So 4 is a perfect square because 2 times 2. 9 is a perfect square because it's 3 times 3. I have a 9, so this, right, is going to be 3 times 3. So I'm pulling that 3 out, and I'm left with a 3 on the inside. I don't have to do this step here because I know that when I square root 9, I get 3. Okay, so if you end up with a perfect square, you don't have to keep going, just square root it, and whatever's left goes inside the square root. Okay. All right, let's look at our triples. So this is just like we did with finding acute and obtuse, except that only thing we care about is, are they equal? Okay, so I have, 5 squared plus 12 squared, and we want to know, is it equal to 15 squared? So 5 squared plus 12 squared is going to be 169. This is 225. They are not equal, so they are not triples. 7 squared plus 15 squared. How does that relate to 17 squared? So over here I have 7 squared plus 15 squared, 274. I want to say that's 289, but let's double check. Yep, 289. These again are not equal, so they are not triples. Again, to be a triple, they have to equal, okay? Use these notes to do your notes quiz, and there is an assignment in Delta Math.